What is up, 7th grade? This is lesson 98, and we're going to be talking about scales and scale factors. A scale simply says how big something is on this scale model or on this map compared to what it is in actual life. So maybe on a map they say 1 inch is the same thing as 1 mile, or maybe on a model they say 1 centimeter on this is the same thing as 24 centimeters on the actual car. But let's just go ahead and jump into that, and we'll talk about scale factors here in just a minute. So a model airplane is built with a scale factor of 1 to 24. If the wingspan of the model is 18 inches, the wingspan of the actual airplane is how many feet? So the larger one of the two is always going to be the real one. So this is going to be the model. So 1 inch on the model is going to be 24 inches on the actual airplane. And so they have a scaled model, and it is 1 over 24, right? 1 to 24, so they give us right here. And they said that the wingspan on the model is 18 inches. And they want to know what it would be on the actual model. Maybe I'll call it x, makes it a little easier. So I'm going to multiply this times this, so it would just give me 1x, or x. And then multiply 18 times 24, which would give me 432 inches. So the actual wingspan on the model would be 432 inches, or if I divided that by 12, that would be the same thing as 36 feet. Here's another one. Sophia is modeling a model of a car from clay. The scale of the model is 1 to 36. If the height of the car is 4 feet 6 inches, what should the height of the model be? So again, I'm going to say 1 over 36, because that's the scale that they give us. And then 4 feet 6 inches is the same thing as 4.5 feet. Or what we could do, since we're talking about this, what the actual is, we can go to that, say 4.5 feet. And we're wanting to know what the length would be on the model. It's very important that we stick, this is model length over actual length, model length over actual length. Make sure we put this in the right place. So we're going to multiply this times this. That's going to give me 4.5. This times this is going to give me 36x. Divide by 36. So get the x by itself, or the height by itself. And I'm going to say 4.5 divided by 36. And that gives me 0.125 feet is my measurement. But that isn't necessarily very helpful because I don't have a 1.25 mark on my measuring tape. So maybe let's convert that into inches real quick. So let's go ahead and say there's 12 inches in 1 foot, so the feet will reduce. So I'm going to multiply that 0.125 times 12, and that's going to give me 1.5 inches. So that 0.125 feet, technically that would be fine, but the 1.5 inches is a lot more helpful. Now, when we talk about scale factor, for this model here, the scale factor is 36. Notice it's the reciprocal of the scale. What that means is that if I took the smaller length and multiplied it by 36, I get the larger length. And we're going to use that concept here as we move into example 3. Notice I have 3 over 7 is equal to 15 over something. So I'm noticing that 3 times 5 gives me that 15. So notice I'm multiplying the top by 5. And that means I could also multiply the bottom by 5, and that will give me what that n is. So 7 times 5 is equal to 35. So that means n is equal to 35. The scale factor here is 5, because the top times 5 would give me this, and the bottom times 5 would give me that. These two triangles are similar. Calculate the scale factor from the smaller triangle to the larger triangle. So what it wants to know is, if I took this, what do I have to multiply by to get this? Or this multiplied by what would give me this multiplied by what would give me this. So there's kind of two ways of doing that. I can say 20 times something is equal to 25. And really I could do that with any pair of these. I have to just use the corresponding parts. Or I could just say this length divided by this length, which is exactly what I'd do here, right? If I was trying to solve for that x, the opposite of multiplication is division. So I divide by 20. So that scale factor is going to be x equal to 25 over 20, but 5 goes into both of those. This one into 4 times, that one 5 times. So the scale factor would be 5 over 4. So notice if I multiplied any one of these lengths by 5 over 4, it'd give you the corresponding length on the larger triangle. Now it is important to note that the scale factor is talking about a linear length. Okay? Linear length like the previous slide we had, just in one dimension. We're not talking about volume or the area of something. So this one says the smaller rectangular prism has dimensions of 2 by 3 by 4 centimeters. The larger one has 6 by 9 by 12. Okay, so I've already drawn these out here. Part A says, what is the scale factor from the smaller to the larger rectangle? So what I'm saying is 2 times something will give me 6. So maybe you might just recognize that here, that 2 times something gives me 6. If I divide both sides by 2, that scale factor would be 3. So for part A, the scale factor between those is 3. So notice if I said 2 times 3, it'd give me 6. 3 times 3, 9. 4 times 3, 12. So the scale factor between these is 3. Now, let's go into part B. It says the area of any face of the larger prism is how many times the area of the corresponding face of the smaller. So let's go ahead and just find an area real quick of this end. Okay, that'd be 2 times 3, so 6. Of this corresponding side, that'd be 6 times 9, which is 54. And notice, so if we want to find out what the how many times larger, I just need to say 6 times something is going to give me 54. Maybe recognize that, I don't know. And that would be 9 times larger. So part B would be 9. And notice, so the linear length is 3 times larger, but the area of the face is 9 times larger. And then part C, it says the volume of the larger solid is how many times the volume of the smaller. So let's go ahead and just find the volume of this one, right? So I'm going to say for part C, 2 times 3 times 4. Well, 3 times 4 is 12. So it's going to be 2 times 12, which is going to give me 24, and that'd be centimeters cubed. And for the larger, it's going to be 6 times 9 times 12. I'll be lazy real quick. 6 times 9 times 12 on my calculator. That gives me 648 centimeters cubed. So what I want to know is 24 times something gives me 648. So if I divide by 24, that something is going to be 27. So the volume of this larger one is 27 times the large of the smaller one. Now, if we call the scale factor, so the scale factor, notice this would be the scale factor squared, and this is the scale factor cubed. And I'm probably getting a little bit ahead of myself. This is something you learn later in 8th grade. But just kind of a good way to start recognizing that. So if you have any questions, please let me know. I would be happy to help you. Good luck, guys.